Geofencing is when the app needs to be open, generally speaking, on the device, and people are using GPS to kind of figure out where a user is. Passive geofencing relies, more so on Wi-Fi. A lot of people think you have to be a navigation app to run GPS in the background. You don't. There is situations that you can run it in. Because we now allow you to draw extremely granular polygons and go right down to, let's say, 10 meters. Before it was like a 100-meter circle. Now it can be like a 10-meter triangle. And the way we've done that is through sensor fusion. If you're using the default geofencing APIs of the phone, there's major limitations: accuracy, timing, the number of fences that you can monitor for. So you're looking for a vendor that can really, monitor an unlimited number of locations globally. You want them to be able to do this in the background passively when the app is terminated. You want them to be able to do this with different shapes and sizes.
You're listening to The Hitchhiker's Guide to the Ecosystem with Steve Statler.
Welcome to The Hitchhiker's Guide to the Ecosystem, the podcast for people designing solutions and entrepreneurs who are location aware. My name is Steve Statler of Statler Consulting, and I have the great pleasure to have Patrick Leddy back with us to talk more about geofencing. Patrick, welcome back.
Hi Steve, hi guys, thanks for tuning back in. So we're back into geofences again today, so I'm ready and able for any question that you can throw at me.
Very, very good. And so time has passed. It's probably a week. I kind of now measure things before Trump and after Trump, so this is kind of another week towards either the beginning of Nirvana or the apocalypse, depending on where you are on the political spectrum. But if I had a boss, he would be talking in my earpiece and say, don't talk about politics. So we won't talk about Donald Trump anymore. But apparently it is very good for hits on social media. I did write an article for Geomarketing once that had Donald Trump as a hook, and apparently it did very well. But
yeah, great clickbait.
Unless you want to say anything about Donald Trump.
I would not. I'd prefer to get into the geofencing.
Oh, okay. So what is the difference between so this session, last session we talked about why would you use a geofence, and this week, if you insist, we're going to talk about how and what you need to do. And so one of the things that you talk about in our book, The Hitchhiker's Guide to the Ecosystem, is this concept of active versus passive geofences. What's the difference?
Yeah, great question. And this kind of like active versus passive, this is really my own terminology. There's various solutions that are out there and people may not even label them this way or understand what they've implemented. But broadly, I divide geofencing into two main groups. Active geofencing is when the app needs to be open, generally speaking, on the device, and people are using GPS to kind of figure out where a user is. Kind of like on the last show, you talked about regional campaigns and figuring out whether people are in New York State or whether they're in California, and you broadly want to know where people are. So that can be a great way to do it. If you only care about where people last use your app, you can use a form of active geofencing to just run the GPS one time when the app first launches and every subsequent relaunch of the app, and then shut it down within a second. So every time they open that app, you're just taking a snapshot. This is the current location, and you'll then do something with that information. Active does have some benefits, in that it is GPS based usually, which means you can be very, very granular and you can figure out where users last use your app down to incredibly granular locations. GPS can go down to sometimes 8 meters of accuracy. That depends sometimes if you're in a building with lots of steel and concrete, which will attenuate the signal, as we know. Active geofencing probably requires less technology to make it work, because really your mobile app is just firing up GPS, finding out where it is, and it's telling your server, you're putting that in a database, and then you can use, actually MongoDB has some built-in functions to do this. You can do geo queries of people within a catchment area of latitudes and longitudes and figure out, where were they last using my app. One of the drawbacks, of course, of this is if you want to know where users go when they don't have your app open, as in when they walk into a competitor or when they come near one of your own stores, you can't rely on customers being helpful enough to have your app open on the screen all the time and at the right time. So really, for a lot of people that we work with, a lot of companies, active geofencing isn't really an amazing solution. It doesn't really blow anyone away, but the aforementioned use cases that I talked about, it is good for generally knowing where your customers reside. When you need to take immediate action, and I mean when users step right into that geofence outside your store, you want to build that attraction and that attention, and then hopefully to get them to come inside and inspire action, you kind of need to do it in the moment. And in the moment, the mobile device, it's probably, the screen is off, it may be in their pocket, they may have another app open, but it's probably likely that your own app is not open on the screen. And that's why passive technologies around geofencing are useful. Passive geofencing relies, more so on Wi-Fi, and that's why I mentioned in the previous episode, Wi-Fi is potentially one of the drawbacks because it is a prerequisite. You do need to have Wi-Fi on for most passive geofencing solutions, but we use the Wi-Fi and we use cell towers to figure out, usually within about 100 meters of accuracy, maybe a little bit lower in some occasions, where you are. And we can do this with the app completely in the background and then wake up the moment you set foot inside that fence. So once you have Wi-Fi on, we can do it. Your app can be closed. The app can be terminated on the device, not deleted or uninstalled. What I mean by terminated is when you swipe apps out of your app drawer. A lot of people think that actually saves your battery, but it doesn't, because all apps are put into a hibernated state. But nevertheless, a lot of people do like to kill apps out of their app drawer for good app hygiene, or maybe they think they're saving some battery power. So you do need to be able to restart in the background and detect that geofence. And that's why passive geofencing is more advantageous than active geofencing, but it requires a different technical set of skills and a different approach and a different set of challenges as well, doing it in the background. Apple doesn't like you running GPS in the background. That's why you got to bring in the Wi-Fi and the cell tower stuff. And of course, even if you could run GPS in the background on iPhones, your users aren't going to be too happy because the battery will be gone in like a number of hours if you're not careful.
So passive is less accurate than active, is that correct?
Yeah, I mean, it can be, because active uses GPS and it uses minimal GPS, usually the last time they opened your app. You can be more accurate around where someone last used your app, but not necessarily where they are now while the app is in the background. Passive is kind of like where they are now when the app is in the background, but there is a trade-off because the app isn't open, and generally we're relying on less accurate technologies, namely Wi-Fi and cellular. We pay a little bit of penalty in terms of accuracy. I think the trade-off is quite it's worth it. The accuracy is still pretty good, down to maybe between 50 and 100 meters, depending on the situation and the app and the environment that the user is in.
It's going to be challenging, isn't it? Because some places have just got loads and loads of Wi-Fi access points and others don't. And then there's the kind of the position of cell towers. And is that uncertainty an issue, or can we just take it for granted you're writing an app for Ireland and you've got a reasonable level of consistency? But I think about the States, and there's just huge variety, whether you're in New York or in the back of beyond in a less populated state. Is that an issue that I should worry about or not?
Yeah, I mean, it's definitely something you need to consider. I mean, if you think about, urban areas with a lot of cell tower sites and a lot of Wi-Fi access points, your resolution is going to be, and your reliability of geofencing based off those data sets is going to be very robust and reliable. I was at Burning Man back in September, which is in Nevada, in the middle of the desert. There's maybe one or two cell towers, not many Wi-Fi routers. So if you've got a geofence in the middle of nowhere, it's not going to work so well. So generally, though, what is helpful around this is the companies that we work with, they're geofencing urban areas, they're geofencing where they have stores, and we haven't really seen too much of a problem with it. Certainly in the use cases we've explored, very few of our customers and prospects are looking to geofence rural or remote areas. So the cell towers kind of get you broadly down to where the customer is. The Wi-Fi is what zooms in and gives you that kind of, I wouldn't say laser-like accuracy, because that's what GPS is, but the Wi-Fi really shortens it down to a very small area. Now the way this works is every iPhone and Android actually works, you may not know this, for people watching at home, but it works as a crowdsourcing device for location data. So if I buy a new TP-Link router or Belkin or whatever it is, and I rip open the shrink wrap and I plug that router into the wall, within, probably within 30 seconds, that router is now in an Apple database. Because my iPhone, which is constantly scanning for new Wi-Fi networks to join, detected the new SSID it hadn't seen before. The iPhone in the background, irregardless of any app, this is the OS that does this. It fired up GPS, it got a latitude and longitude, a high accuracy one of where this Wi-Fi access point was seen in the real world, and then it goes back to an Apple database. And every iPhone and Android in the world do this on a crowdsourced level. They map all the Wi-Fi access points. But why do they do this? The reason they do this is so that apps have pretty decent, pretty good location awareness without the battery expense of constantly having to fire up GPS. And it works, and it actually works very, very well. So that's one of the reasons that we rely on this, and a lot of companies rely on this for geofencing. The Wi-Fi data, your phone's already out there, it's doing its thing. A phone's being a phone, it's connected to a cell tower so it can get text messages and receive phone calls. It's also constantly sending out a flood of Wi-Fi ping requests to say, is there any interesting Wi-Fi networks around here I might like to join? So our SDK and anyone who's building their own geofencing technology in their app, you just piggyback on these pings of the phone already doing its thing, being a phone, and then you get access to some of this highly accurate location data with minimal battery expense. And that's what makes it kind of an interesting implementation.
So is there any more to be said about this battery life issue? Because it seems like GPS, we have this wonderful constellation of satellites we can use, but we're really draining the battery. Apple doesn't like us using GPS a lot. So we have to think about that when we want to get our app accepted. Is there anything else to be said in terms of battery, optimizing for battery?
I think you want to minimize GPS completely. When you're doing active fencing and you're using GPS in the foreground, you kind of just want to do it the first time they open the app. Well, you want to do it every time they open the app, but you don't want to run the GPS radio for the whole duration of that app session. But just in the first second, where are they? Where was the app session today? That's kind of good enough. When it comes to background GPS usage, Apple is very careful about how they let you use this and run this. You can actually, a lot of people think you have to be a navigation app to run GPS in the background. You don't. There is situations that you can run it in. Usually if you're running GPS in the background the whole time, it does significantly damage the battery. Not permanently damage, but it lowers the battery power on the device.
Yes.
iOS and Android now come with a settings screen that show you which is the offending app that's causing the battery drain. So if you're doing a lot of battery drain, users are going to figure out there's some app in their phone draining their battery. They're going to look up the summary battery usage and they're going to click that X on your app and delete you for good. Also, if you are running GPS permanently in the background to do what I would call a very crude version of passive fencing, there are companies out there that have built this themselves. There are even solutions on the market offering geofencing, which they claim is extremely accurate, and of course it is, because they're using GPS the whole time, passively when the app is in the background. But the battery drain is just off the charts, ridiculous, unusable by users. You also have to put a warning on your app if you're using GPS in the background, and that warning has to go on the app description of the App Store, which says, warning, this app uses background GPS and may excessively drain your battery. Yep, you actually have to put that on your app description.
Wow.
That's a little bit of a turn off, it doesn't really set the stage. What we do, and we've done, a bit of a marked change between, Pulsate Geofencing 1 and Pulsate Geofencing 2.0, is we now allow you to draw extremely granular polygons and go right down to, let's say, 10 meters. Before it was like a 100-meter circle, now it can be like a 10-meter triangle. And the way we've done that is through sensor fusion. And that means that we're looking at a range of different things on the device. So first of all, has someone entered, a region around a smaller fence? So we have a small polygon, we're interested when people breach that. So we put a bigger area around that, we can step up our monitoring as soon as people enter the general catchment area of the smaller fence. Then sensor fusion, accelerometer data, and other sensors on the device, gyroscope data, ambient light. There's lots of things that you can look at and give you clues whether the phone is in motion or not. If the phone is connected to a power source, it's probably not in motion as well. There's APIs to check these things. This is what I call sensor fusion, and this allows you to decide when and where you want to use GPS. So when you use GPS, you can burst it. up and down in a certain pattern or algorithm when you're sure the user is actually in motion. So if you're using GPS, do it right. Be careful with it, develop a pattern around it.
All right. This is a great one of these things where your head starts to spin because there's just so much to this. And we've talked predominantly about iOS. Just say a few words about the difference between geofencing in iOS and Android.
Yeah, I think, the differences, if we go back in time, the differences were more apparent. We're seeing definitely a convergence in the way these geolocation services, and if you look at core location and region monitoring, which are the iOS APIs, Android has its equivalents. So really, they are very similar. One thing that I would say in terms of the differences is very much that with Android, you can kind of like, as with everything else as a developer for Android, you can kind of do what you like. So there's a lot of flexibility and a lot of freedom, too much in some situations, where you can kind of just go a bit mad in how you implement the solution, and you can really cause a lot of battery drain. You can do all sorts of things. So it's a lot easier to do this on Android, but it doesn't necessarily mean the user experience is going to be good. Apple, kind of like in their walled garden, they're protecting that user experience of their sacred device. That's a good thing as a developer, because I guess those constraints force you to innovate with the solution and make sure that you're not sacrificing the user experience. Android's just a little bit more of the Wild West in terms of what you can do.
Very good. And any last comments on just selecting a geofence product? I decided I just don't want to learn all the stuff that you described, and I just want someone who's going to solve the problems for me. What do I look for?
Sure. If you're using the default geofencing APIs of the phone, there's major limitations: accuracy, timing, the number of fences that you can monitor for. So you're looking for a vendor that can really, monitor an unlimited number of locations globally. You want them to be able to do this in the background passively when the app is terminated. You want them to be able to do this with different shapes and sizes, circular regions and polygons, and probably, in this day and age, to go down to maybe, probably 10 meters of accuracy and maybe even a little bit lower in some situations. You also want to do this without the battery drain. So you probably want to see sub 5% battery utilization across the day for your app running that geofencing SDK. You want to make sure that the provider is not using GPS in the background the whole time. And you should probably ask them whether their SDK requires the warning to be put on the App Store description about the background GPS usage. Usually a lot of our competitors, the answer is yes, you have to put that on the App Store description. So I think there's some questions that are worthwhile asking.
Very good. Well, Patrick Leddy, CEO of Pulsate, always an interesting discussion. Thanks so much for your time.
Cheers, Steve. Thanks, guys, for watching. See you next time. Cheers.